this is the cantilever section. In the cantilever section, you can see that one end it is a fixed and another end it is a free. So you can see very clearly that this end is the very free fixed end. This end is the free fixed end, and this end is the free end. In the fixed end, it is known that the total number of the reaction at the point A is the 3 number of the reactions. In the 3 number of reaction, there will be one horizontal, one vertical, and one moment. So there will be 3 more forces: horizontal force, vertical force, and a moment will be introduced. So a simple cantilever beam section is being converted that into a free body diagram. So like this. So as I told, so there is a fixed section at one end. So due to this fixed end, we will get one vertical force and another horizontal force. So horizontal force and moment will be introduced. So there will be 3 unknown forces will be there. Okay. So the next you have to convert this, the 10 kilonewton per meter UDL, you have to convert that into concentrated load. How? 10 into 2, 20 kilonewton. A magnitude of 20 kilonewton will be acting at the center. So you have to find out the only thing is here the same, whatever the concentrated load 10 kilonewton is there, kept as it is. Now your aim is to find out the 3 unknown forces at A only. Okay. So what you do is you just take the horizontal force. If you take this sigma fx is equal to 0, see here, if you take sigma fx is equal to 0, so there will be no unknown forces. There will be no unknown forces here, only is ax is there. So there is no another forces, horizontal forces there. So sigma fx is equal to 0. For that one, there no, due to no horizontal forces except ax, so that's why ax value will become 0. Next, what you do is you take the vertical force, summation of vertical forces, upward direction as positive. You take upward direction as positive. After taking upward direction as positive, so this one ay is positive plus ay, and minus 20 is moving, this force is moving towards the downwards, so it is 20 kilonewton, and the another force of 10 kilonewton, this is also moving towards the downward direction, so it is 10 kilonewton at the downward, so that is equal to 0. So if you calculate minus 10 into minus 20, it is minus 30. If you send this side, it will become 30. So totally finally the ay, it is 30 kilonewton. So next is the only unknown forces, what is that is ma. So this moment at a you have to determine. So what you do is take moment at a is equal to 0. Okay. So you take anti-clockwise direction as positive. You can take any direction, either clockwise or anti-clockwise direction, or anything as positive. So according to your convenient. So I am taking the anti-clockwise direction as negative. That's all. Okay. So the ma, as even though I am taking moment at a, so I should not take any other forces, horizontal forces and vertical forces I should not take into consideration. So ax and ay I will not take into consideration, but moment at a I should take the moment at a. Moment at ma is there, no? I want to take this one because this is another reaction at a due to the cantilever section. So moment at a, it is rotating in the anti-clockwise direction, so that's why it is positive. Okay. So next is 20 into distance of 10, so it is rotating in the clockwise, so that's why minus 10 minus 20 into 1. So next another force is 10, so this is also moving towards the clockwise direction. So that is minus 10 into 4. Okay, 1 1 2 4. So totally 4 meter distance, 4 meter into 100 into 10, 4 into 10. So it is moving in a clockwise direction, so it is minus 10 into 4. So finally if you calculate this moment at A, you will get it around 60 kilonewton. So finally you have determined Ax value, Ay value and moment at A. So this is how the calculation of the cantilever. So this is a very easiest problem. So please work out on this.